Why isn't Python very good for functional programming? I have always thought that functional programming can be done in Python. Thus, I was surprised that Python didn't get much of a mention in this question, and when it was mentioned, it normally wasn't very positive. However, not many reasons were given for this. Lack of pattern matching and algebraic data types were mentioned. So my question is, why isn't Python very good for functional programming? Are there more reasons than its lack of pattern matching and algebraic data types? Or are these concepts so important to functional programming that a language that doesn't support them can only be classed as a second-rate functional programming language? Keep in mind that my experience with functional programming is quite limited.
The question you reference asks which languages promote both VU and functional programming. Python does not promote functional programming even though it works fairly well. The best argument against functional programming in Python is that imperative/the use cases are carefully considered by Guido, while functional programming use cases are not. When I write imperative Python, it's one of the prettiest languages I know. When I write functional Python, it becomes as ugly and unpleasant as your average language that doesn't have a BDFL. Which is not to say that it's bad, just that you have to work harder than you would if you switched to a language that promotes functional programming, or switch to writing Python. Here are the functional things I miss in Python. Pattern matching, tail recursion, large library of list functions, functional dictionary class, automatic currying, concise way to compose functions, lazy lists, simple, powerful expression syntax. Python's simple block syntax prevents Guido from adding it. No pattern matching and no tail recursion mean your basic algorithms have to be written imperatively. Recursion is ugly and slow in Python. A small list library and no functional dictionaries mean that you have to write a lot of stuff yourself. No syntax for currying or composition means that point-free style is about as full of punctuation as explicitly passing arguments. Iterators instead of lazy lists means that you have to know whether you want efficiency or persistence, and to scatter calls to list around if you want persistence. Iterators are used once. Python's simple imperative syntax, along with its simple LL1 parser, mean that a better syntax for if expressions and lambda expressions is basically impossible. Guido likes it this way, and I think he's right.
Guido has a good explanation of this here. Here's the most relevant part. I have never considered Python to be heavily influenced by functional languages, no matter what people say or think. I was much more familiar with imperative languages such as C and Algol 68, and although I had made functions first-class objects, I didn't view Python as a functional programming language. However, earlier on, it was clear that users wanted to do much more with lists and functions. It is also worth noting that even though I didn't envision Python as a functional language, the introduction of closures has been useful in the development of many other advanced programming features. For example, certain aspects of new style classes, decorators, and other modern features rely upon this capability. Lastly, even though a number of functional programming features have been introduced over the years, Python still lacks certain features found in real functional programming languages. For instance, Python does not perform certain kinds of optimizations, for example, tail recursion. In general, because Python's extremely dynamic nature, it is impossible to do the kind of compile time optimization known from functional languages like Haskell or ML. And that's fine. I pull two things out of this. The language's creator doesn't really consider Python to be a functional language. Therefore, it's possible to see functional-esque features, but you're unlikely to see anything that is definitively functional. Python's dynamic nature inhibits some of the optimizations you see in other functional languages. Granted, Lisp is just as dynamic, if not more dynamic, as Python, so this is only a partial explanation.
Scheme doesn't have algebraic data types or pattern matching, but it's certainly a functional language. Annoying things about Python from a functional programming perspective. Crippled lambdas. Since lambdas can only contain an expression, and you can't do everything as easily in an expression context, this means that the functions you can define on the fly are limited. Ifs are statements, not expressions. This means, among other things, you can't have a lambda with an if inside it. This is fixed by ternaries in Python 2.5, but it looks ugly. Guido threatens to remove map, filter, and reduce every once in a while. On the other hand, Python has lexical closures, lambdas, and less comprehensions, which are really a functional concept whether or not Guido admits it. I do plenty of functional style programming in Python, but I'd hardly say it's ideal.
I would never call Python functional, but whenever I program in Python the code invariably ends up being almost purely functional. Admittedly, that's mainly due to the extremely nice list comprehension. So I wouldn't necessarily suggest Python as a functional programming language, but I would suggest functional programming for anyone using Python.
Chamado Simon, aliás, considera-se um desfibinho.